Assalamu alaikum, grade 9s. So today we are going to jump into section 6.2, which is all about interpreting graphs. What we're going to do is we're going to talk about some definitions relating to graphs. We're going to talk about how to analyze data given to us in graphs, how to come up with an equation of a graph, how to get certain information that the graph maybe doesn't give us directly. Before we start though, I want to say that this is a really important topic. If there's anything that we do in grade 9 math that's going to come up again in grade 10, it's definitely this section. Okay, so knowing, for example, what slope is, what y-intercept is, what this formula is, those are things that are really important for grade 10, not just for math, but also for science 10. So if you guys can understand this stuff now, it will make your grade 10 experience a lot easier. So that's the first thing I wanted to say about this section. The second thing is that this is a lot of writing and definitions at the beginning. So what I'm going to do is I'm going to actually fill it in myself, and then you guys can pause the video, fill in the definitions once they're on the screen, and then unpause to hear me go through the explanation of the definition. So I'm actually going to write only one at a time. I'm not going to fill them all in at once and then explain them all at once. So we'll start with interpolate, then extrapolate, slope, then y-intercept. So this is the definition of interpolate if you want to pause and write it down. So interpolate basically means to estimate a value between two given values within a graph. So let's say, for example, I'm going to use this graph right here as an example. So, let's say we have this graph where we have, the amount of distance traveled and how much gas it would cost to travel those distances. So, 100 kilometers, it's $50, 200, $100, and so on. So this is kind of our trend in our graph. Can we extrapolate? Like, let's say, for example, I want to travel just 150 kilometers, which is between 100 and 200. Does it make sense to come up with a value in between these two? Does it make sense to say that gas at that point will probably be $75? Well, yeah, it does, because it makes sense to have gas at $75, and it makes sense to, to have a distance between 100 and 200 kilometers. But you can only use this method when it makes sense to have a value between these two given values. So interpolating basically means you coming up with getting information from the graph in between the given points of the graph, which you can do for the most part, right? But there is sometimes where it doesn't make sense for us to use interpolation. For example, with this graph right here, let's say we have this graph that says number of people versus cost. So let's say, for example, number of people that you would be feeding at a dinner and how much it would cost you to feed that many people. So for one person, it's $20, two people, $40, three people, $60, and so on. Does it make sense in this case to interpolate? Can I say, okay, at this point, how much money would it cost? Well, it makes sense on the cost end, but it doesn't make sense on the x-axis, because 1.5 people doesn't exist. You can't have 1.5 people. So, for example, 1.5 people does not exist, or it doesn't make sense. So in this case, we cannot interpolate. So we cannot interpolate. So you can only interpolate when it makes sense to have a value in between those two given values. All right, guys. So this is the definition of extrapolate if you want to write it down. You can pause and write it down. So extrapolation basically means to estimate a value beyond a given set of values. So with interpolation, it was between two given values. Extrapolate is beyond a given set. So if you look at a trend of a graph, for example, this one, and it asks you to figure out something that's maybe not given in the graph. For example, in this, how much money does it cost versus distance traveled graph? If I ask you how much will it cost for 500 kilometers traveled, you can probably figure that out based on the trend of the graph. If it continues and if it's at 500, you can probably figure out what the cost would be based on the pattern that's happening in the graph. It's going up by 50 each time. Okay, so you can extrapolate in this graph where you're looking at the trend of the graph and you're making an estimation beyond the given set of values. Okay, but again, just like with interpolation, you can only use this method when it makes sense to have values that are greater than the given values. So for example, here we have a graph that shows a relationship between angles and their quadrants in a graph. And we have the angle 90, 180, 270, and 360. And they line up with which quadrant they are at. Now, here, if I tell you to extrapolate a number here and figure out what quadrant it's in, is that possible? No, it's not, because angles only go up to 360. There is no angle greater than 360. And in addition to that, there's also no quadrant greater than 4. There's only 4 quadrants, 1, 2, 3, 4, in a grid. So you can't go beyond this data and say, oh, in quadrant 5, it's going to be at, 400 and some degrees, because there's no such thing as angles greater than 360. So you cannot extrapolate here. So how do you remember the difference between interpolate and extrapolate? Well, just like in their names. So interpolate, inside the graph, extrapolate, exiting the graph, so going beyond the graph. So that's kind of how you can remember their names. So our next definition is slope. And this is the definition if you want to pause and write it down. Slope, represented by the variable m, in a formula, you'll see it written as the letter m, means the steepness of a line. And that's the basic definition of slope, how steep a line is. So for example, if you look at these 3 different graphs, you have here a line that's going up. So we say this has a positive slope because the line is sloping upwards. Here the line is going down. We call it a negative slope. And here the line is going straight, so we say it doesn't even have a slope. It's a slope of 0. You can actually there's different levels of steepness, right? You can have a line that is like this versus a line that is like this versus a line that is like this. So in a graph, if this was our graph right here, and these were 3 different lines, line 1, line 2, and line 3, these 3 lines have different slopes because they have different steepness. So the slope is something that we're actually going to be able to calculate. So the steeper the line, the bigger the slope. And we're actually going to learn how to calculate slope. So another way of looking at the words, the definition for slope is the change in y over the change in x. And this is something that you may have seen before in a formula that looks like this: delta y over delta x. This little triangle is a Greek letter called delta, and delta means change in. So the change in y divided by the change in x. So if you have a table of values, of x and y values. You have 1, 2, 3, 5, 10, 15. You can find the change in y, where here it's going up by 5, and the change in x, here it's going up by 1, and you can divide them to find the slope. The change in y was positive 5, the change in x was positive 1, and if I divide them, I get 5, which is equal to our slope, m. So this is how we can actually calculate the slope of an object, delta y over delta x. Another way of calculating the slope or thinking of slope is with the formula rise over run. Rise representing the y-axis because it's rising up, and run representing the x-axis. Okay, if you're running horizontally. And this is basically the same thing as this formula right here, y over x, or change in y over change in x. But these are the different ways that you could see it, rise over run, or delta y over delta x. And even you can see it as, instead of writing delta y over delta x, some people may write it as y2 minus y1 over x2 minus x1, which is basically what we did here. We took two values of y, this one and this one, and we subtracted them to find the difference or the change. Same thing with x. 2 minus 1 was 1. We subtracted them to find the change in x. So these are three different ways that you can see the slope formula being written. Delta y over delta x, rise over run, or this one, y2 minus y1 over x2 minus x1. There's three different ways that you could see it, and they are all correct. In high school, in grade 10, you're going to see it more as this one, y2 minus y1 over x minus x1, and you're going to be referencing it as rise over run as well. Another way you can look at it based on just a graph, if you don't have a table of values, is you can find the slope by checking the rise over run on a graph. So for example, to get to this first point right here, or between the 2 points, you pick any 2 points that you want. In the first example, we did these two. So in this one, I'm going to pick the second point and the third point. So to get from the second point and the third point, the rise, how much did it go up in y? It went from 10 to 15. So the rise was a rise of 5, and the run horizontally, it went up by 1. So if I do rise over run, the rise was 5, the run was 1, so 5 over 1 is 5. And so we know that our slope is equal to 5, just like what we got in this example right here. It's the same numbers. Okay, so the slope of a line is how steep the line is, but it's also something that we're going to be having to calculate using one of the three formulas. So our next definition is the y-intercept, which is represented by the letter B in a formula. If you want to pause and write down the definition first. So the y-intercept is the point where the line touches the y-axis. So the actual interception point. If you watch hockey or any sport, you know what an interception is. It's when two things cross each other, right? Or two players cross each other, or they block each other. So where does the line intercept the y-axis? That is the y-intercept. So in this graph, this is where it touches the y-axis. So the y-intercept is at the number 6. So the letter that represents the y-intercept is the letter B. So here we would say that B is equal to 6. And here was a flat slope, right? So there's no actual slope here. Here, where does the line touch the y-axis? That would be down here at the 0 point. So here the y-intercept would be 0. And on this graph, where does it touch the y-axis? That's right here at 3. So B would be equal to 3. And it's just as simple as that. Just looking at the graph, seeing where the line touches the graph. This is going to be really helpful if you know that b is equal to the y-intercept. Because then we have our formula, right? We have this thing called the slope-intercept formula, which is y is equal to mx plus b. And we know already that m represented the slope and b represented the y-intercept. And so if we have those two pieces of information, we can plug them into our formula. So what the slope-intercept formula does is that if you have a table of values of x and y, it's saying that no matter what x and y you plug into the formula, your m and b will stay the same, and if you plug in whatever x, it will give you the y properly. So, for example, if we have a table of values like this, where we have x is 1, 2, and 3, and then y is 3, 5, and 7. So we can find the slope by doing rise over run or delta y over delta x to find our slope of this table of values. So the change in y, it's going up by 2 each time, and x is going up by 1. So that would be 2 over 1, which is equal to 2. Now, if I had to find the y-intercept, I could plot it, but if I don't want to plot it on a graph, there's another way you can find the y-intercept using a table of values. The other way is to say, okay, I have this formula that says y is equal to mx plus b. And I just found my m, right? M is the slope. So I can plug it in. Y is equal to 2x plus b. And I still don't know what b is. So to figure out what b is using a table of values, all you have to do is plug this formula in and see what's missing. So this is saying that to get y, you just have to take x and multiply it by 2. And then add a number, but we need to figure out what that number is. So let's look here at our table. So if I take y, in order to get y, it's saying take x and multiply it by 2. So 1 times 2 gives me 2. So 1 times 2 is 2. So what would I have to add right here? What would be my plus b in order to get me the y value? Well, in this case, I would have to add 1. So let's see if it works for all of them. So we're saying times 2, then plus 1. So 2 times 2 is 4 plus 1. Yep, that gives me 5. 3 times 2 is 6 plus 1. Yep, that gives me 7. So if I put those numbers into my formula, y is equal to 2 times x plus 1. In order to get the proper formula, these are the numbers I needed for the slope and for the y-intercept. The slope is 2, the y-intercept is 1. So why is this formula helpful? Well, this is for sure going to be something that you're going to have on your, in Math 10. But this is helpful on an exam. Let's say I give you a graph, okay? And an unknown graph, and then I tell you what's the formula for this graph. And let's say it's the one I have here. 3, 4, 5, 6, and then 7. And the line doesn't look like that. Looks like 1, 3, 2, and 5, 3, and 7. It looks more like this. So point 1, I have 3 for y, point 2, 5, and point 3, 7. So if I give you this and I give you like a multiple choice question and I say which one of these represents the slope of the line, you should be able to say just by looking at the graph, and I actually drew it wrong, but just by looking at the graph, you should automatically be able to eliminate any answer that doesn't have a +1 as the y-intercept, because it actually shows you on the graph. So we're going to get to using this formula in a sec, but this is all the necessary information you need to interpret graphs. Okay, so let's do an actual example dealing with linear equations. So the whole point of section 6.2 is to interpret graphs, but really the end goal of it is that you'll be able to develop or get a linear equation out of a given set of data, whether that's a graph or it can even be in statement form. So here we're using two methods to find a linear equation from a set of data. So method one is use a statement to create the equation. So here we have a statement that says a car rental company charges a flat rate of $35. I'm going to use my highlighter. A flat rate of $35 plus 45 cents per kilometer for renting a car. The graph below shows the cost of renting a car based on the number of kilometers driven. So the graph shows the information there, but we're going to actually come up with a linear equation using just this sentence, and then we'll do it with the graph after. So we know that the formula for an equation was the slope-intercept form, which is y is equal to mx plus b. Now, the way that you can get this, the way that you want to write out the equation is the y and the x don't change. They stay as y and x. The only thing you need to replace is the m and the b. And you have to figure out which number is m and which number is b. The way that you can do it is by looking at the question and the equation. So if you look here, m, the slope, is actually a coefficient, right? It's attached to x. It's a coefficient of x, which means x depends on the slope, m. If m is 1, x is multiplied by 1. If m is 5, x multiplies by 5. If m is 15, x multiplies by 15. So they are related and they're dependent on each other. The thing that's not dependent on anything, we call it a constant, which doesn't have a variable attached, is the b. So b is a constant and m is a coefficient. And x and y are variables. So we're going to go to our sentence and we're going to figure out which one of these things is the constant, which means it doesn't change. Or which, in other words, it's not affected. And this one is dependent. Okay, it's dependent on something else. Okay, so if we read here, the rental company charges a flat rate of $35. Flat rate means you're going to get charged that amount no matter what. Plus $0.45 per kilometer. So based on these two pieces of information, the flat rate is actually the constant, because that's something you're adding no matter what, plus $45 per kilometer. So if we redo this equation, y is equal to, the m would be 0.45, x stays the same, and then plus the constant would be $35. So the rental cost would equal to 45 cents per kilometer, which is x, plus a $35 flat rate that you have to pay no matter what. And this is the equation that represents the cost of the rental car. Now, that's how you do it based off of a sentence or a statement. How do we do it based on our graph? So this is the graph of the information where we have how much distance is traveled versus the cost that you have to pay for the car rental. Now, here we're going to find the slope using the graph and using a table of values. Just by looking at this graph, The y-intercept we know is for sure above 30. Between 30 and 60, this is about 45. So we know it's between 30 and 45. Okay, so what we're going to do to make it easier for us is we're going to kind of estimate the values a little bit. So what you want to do is you want to start off with your first point, which x is at 0. And when x is at 0, y is around, let's say, 35. And then our next point, you don't have to do every single point in the graph, but let's say our next point is over here, where x is 50, and then y is maybe around, if we say that this one was 35, which is just a little above 30, then this is this one is probably 55, which is just below 60. So when x is 50, when the distance is 50, the y is 55. And then you can keep going. You can keep adding if you'd like. So when x is 100, what would y be? Okay, maybe around 80. So when x is 100, y is 80. And you can keep going if you'd like, but realistically, you only need 2 set of points. You don't even need to go beyond 2. So what you do now is we need to step 1 is find the slope, because we know our equation is y equals mx plus b. We know that y and x stay the same. We don't change them. We need to find m and b. So our slope, how do we find it? Well, we know that we can do rise over run, or y2 minus y1 over x2 minus x1, or delta y over delta x, right? So the change in y over the change in x. So you pick 2 points, and it honestly doesn't matter. It honestly doesn't matter which 2 points you choose. Like, you can choose the first 2, you can choose the first and the third, you can choose the second 2. It doesn't matter. So I'm gonna just choose the first 2 points, just because it's easy to work with 0. The subtraction just becomes a lot easier. So I'm gonna say y2 minus y1 over x2 minus x1. So my second y value was 55, and my first one is 35. And then if I look at my 2 x's, the second one was 50, the first one was 0, so 50 minus 0. Then you simplify. 55 minus 35 would be 20, and 50 minus 0 is 50. And then if you reduce this, you get 2/5, which we know is around 0.4, which is pretty close to what we got here for our slope, 0.45. It's not going to be 100% the same because obviously we didn't really interpret our graph 100%, but because there's a big gap between each point. But that's why if you're given a statement, it's actually more accurate to use the statement that's given to you than to use the graph. But here we know we're on the right track. If we use different points, like if we used so if we label these 0.1, 0.2, 0.3, if we used 0.3 and 0.1, let's say, where we have our y2 is 80, our y1 was 35, our x2 is 100, our x1 is 0, and then you subtract them, you get that 100 minus 0 is 100, and 80 minus 35 is 45, which gets you 0.45. So just based on this information, this is probably a more accurate reading of the graph. And I probably messed up on point number 2. It doesn't really matter as long as you can show your work and that you're pretty close, which we are. 45 and 0.45 and 0.4 are very close. So step 1 was to find the slope. Let's stick with the more accurate answer, which was 0.45. Step 2 is to find the y-intercept. So we want to see what the difference is that's needed to make it up. So if we had 0 and 35 here for one of our first point, and we plug it into our formula, y equals mx plus b, we know that, so it's saying to get y, you do 0.45 times x plus something. And we have to figure out what that something is. So if we plug in our numbers, y is equal to 0.45, and then x is 0, plus something, we know if we plug in both our numbers, x and y is 35. Oops. So 35 equals 0.45 times 0 is 0 plus something. So 0 plus what gives us 35? Well, that would have to be 35. So that means our b value or our y-intercept had to have been 35 in order to make up the difference that we needed. So that is our equation, which is the same thing that we had the first time. So if we write our equation, y is equal to 0.45x plus 35. That's slope-intercept form. You have the slope, you have the y-intercept, and you have your y and x. You can even check and plug in your numbers into the formula to see if your left side equals your right side, to see if your equation is actually correct. So for example, we have y is on the left equals 0.45x plus 35. And so if we plug in a different number, so when x was 100, y was 80, if we plug it in to make y 80, 0.45 times 100 plus 35, does it equal? So 0.45 times 100 is 45 plus 35, and 45 plus 35 is equal to 80. So our left side does equal our right side. So that's how we know our equation is correct. Okay. Our last example is, now that we have a formula, or now that we have a graph, can we interpolate and extrapolate from given data? So there's 2 ways you can do this. You can use your formula to find the exact numbers, or you can use the graph to find approximate values. So for example, it says, what is the rental cost after driving 50 kilometers? You can go to your graph and say, when we drive 50 kilometers, what is the cost? And you can kind of make a guess about what the cost would be here. If you don't want to guess and you want a more accurate answer, you can just plug it into the formula. We know that with y and x, which one is the y-axis? That's the cost. And the distance is the x. So if it's asking us for the cost, that means we want to find y. So, and we're plugging in our value for x. So 0.45 times 50 plus 35, because we're just plugging it into our formula. And then when you multiply it, 0.45 times 50 plus 35 should be 57.5. So the cost would be $57.50 if you drove 50 kilometers. So this is the accurate answer. And this is the reason why our slope was a little bit off here, because we put it as 55, but it's actually supposed to be 57.5, which is fine. Again, it's not that big of a deal. This is the more precise answer though. All right, the next one, what is the rental cost after driving 75 kilometers? Again, you're trying to find the cost, which was the y-axis, and the distance is the x. So you're going to plug it in. 0.45 times 75 plus 35. 0.45 times 75 is 33.75, and then add that to 35, you get 68.75. So $68.75, and that's a precise answer. One more time, again, you want to find the cost after driving 300 kilometers. You're still trying to find y. 0.45 times 300 plus 35. So 0.45 times 300 gives you 135. And then add 35 to that, you should get $170. So you're just plugging numbers into your formula. How about if we flip it? Instead of us finding the y or the cost each time, how about if they give us the cost and it asks you how many kilometers? So they give you y and you need to find what x is. So we know y is equal to 0.45x plus 35. Let's plug in what we have. So the cost they said was $115 equals 0.45x plus 35. And now you just have to work backwards to solve for x. So minus 35, cancel these out. 115 minus 35. 5 minus 5 is 0. 11 minus 3 is 8. So that would be 80 equals 0.45x. And these canceled out. And now to get x, you have to divide by 0.45, divide by 0.45. These cancel. So x equals 80 divided by 0.45, which is 177.7777, so 78 kilometers. So that's how many kilometers you need to if you're spending $115. We can check if this is accurate. Like if you go to your graph and you look at around where 115 would be, I'd say maybe around here, and you go to your graph and you click it. We said it's around 177, which it would make sense that that's the value right there. So you can always go back to the graph to check if you're on the right track. All right, guys. So I want you guys to practice doing some interpolation, extrapolation. Pause the video. I know this was a lot of me talking, but pause the video and try these two show you knows. And when you come back, I will have the answers posted. All right, grade 9s. These are the answers to the show you know. Please make sure that you are getting the same answers and your textbook homework or practice is written here. Only questions 5 to 7 and only the odd ones. Sorry, 5 to 17 and only the odd ones. So 5, 7, 9, 11, and so on. Okay. Thank you guys, and I will see you for 6.3, inshallah.